Good afternoon or good evening, everyone. Hopefully you're doing well. We have our video for today, and it's on lesson 122, how can I solve the proportion? Now, proportion is a very important skill that we're working on, and we started talking about proportional relationships in class, and hopefully you feel comfortable with what proportional relationships are, because we're taking it to the next level of how to solve proportional relationships, okay? Now, here's what I need to tell you up front. This is a challenging lesson. So if you are half asleep, this is going to be a problem. If you are distracted, this is going to be a problem. This is one of those lessons where you may have to watch this multiple times to make sure you understand. You may have to go back to this to review later on multiple times. It is one of those important lessons that you need to follow. So please, please, please make sure that you are alert and ready to go. If at any point you need to pause and go back, do it as many times as you need, but make sure you understand this. We will talk some about in class, and we will practice some in class tomorrow, but this is the bulk of the material, okay? Strategies for solving proportional relationships. Proportional relationships can be identified in both tables and graphs. In this lesson, you also used both of these representations to make predictions, in the last lesson, about proportional situations. Today, you will continue to develop strategies for solving proportional situations using an equation. And here's our problem, problem 152. Kenny can make 7 origami, which is when you fold paper, okay? So he can make 7 origami cranes. Cranes are a type of bird. I know, it's kind of weird. He can make 7 origami cranes in 10 minutes. He read a story about a girl who made 1,505 cranes. So he was curious how long it would take him to make that many without stopping. Now, by the way, also today you will need a calculator. So if you have a calculator, it's going to make life a whole lot easier. So please make sure you have a calculator available. Okay? All right. So he can make 7 cranes in 10 minutes. He heard about a girl who can make 1,505, and he wondered how many he could make or how long it would take him if he wanted to do that without stopping. So he went ahead and made a table like this below. And what I want you to do is I want you to look at the table. Now, here's some important things. Number 1, in 0 minutes, he would make 0 cranes. And by the way, do you notice it talks about cranes here and time here? So he's folding the cranes and seeing how long it takes. So the time depends on the cranes. That's why this is on this side. So we're starting with how many cranes he can fold and checking how much time it would take. He can do 7 cranes in 10 minutes. So the question is, how long would it take him to do 1,505? The question I have for you is this a proportional relationship? Well, if you remember the 2 things we talked about, we said number 1, it must go through the origin of your 0.00, and it does that right here. And it must go by a consistent amount. So if I had 7 and 10 here, so if I had 14 here, this should be 20, right? Because if I take this twice, that should be this twice. And what we're saying is, well, does that make sense? Could I have 14 and 20? Yeah, because he's doing it the same rate. So 7 cranes every 10 minutes. So this is a proportional relationship. We're going to see how long it takes him to do 1,505. Well, he decided that instead of using a table or graph, he would represent it as a fraction, as a ratio. So he just put the number of minutes above the number of cranes. Okay, you could have done it a different way, but that's how we do it. 10 minutes over 7 cranes equals question mark minutes over 1,505 cranes. And that's what we're going to work on with today. Now, here are 3 methods we're going to talk about to solve this proportion. And maybe you feel comfortable with this. Maybe you even remember some of these. Or maybe this is your first time seeing it. So please follow with me to the best of your ability. And we're going to review back to 6th grade and talk about some of the stuff. Here is the first one. The first method is the giant 1 method. Now, the giant 1 method says the following. If you have any fraction that is the same number on top as on bottom, as a numerator and denominator, so like 5 over 5, what does that mean? Well, 5 over 5 means you have 5 pieces of pie and you have all 5 of them. So that means you have the whole pie. Or that means you have, this is also division problem, so it's 5 divided by 5. Regardless, 5 over 5 is equal to 1, right? So is 7 over 7, or 1,739 over 1,739. all those numbers, all those values, when it's the same number as the numerator, as the denominator, they always equal 1. Well, on a fraction, well, I could say this. I can say, what can I do on my fraction up here to get it to this fraction right here? A proportion says that this ratio is the same. So I should be able to do the same thing to 7 to get 1,505 that I do to 10 to get this number here. And so the giant 1 method says, okay, 7 times what? Because I always want to multiply. 7 times what gives me 1,505. Okay? And to do that, what can I do? How can I find that number? Well, if 7 times something is 1,505, I should be able to reverse that process to get my answer. Just like if I said 5 times what equals 10, well, you know it's 2, right? What can I do with 10 and 5 to get that? Well, I can do 10, this number, divided by this number, 5, to get my answer here, 2. Okay? So I'm going to do the same thing here. I'm going to do 1,505 divided by 7. And 1,505 divided by 7, do it on your calculator, please. I want all of you to do this on your calculator. It's really powerful to do it yourself. So I want you to see it. 1,500, if you need to pause the video, get a calculator. 1,505 divided by 7 is 215. So if I took, that means, holy cow, he's got to do 215 sets of these 7 cranes. If he does 250 sets, 15 sets, he will get 1,505. Awesome. But here's the thing. It doesn't make any sense to just multiply that. What I am going to multiply by is, well, if I multiply by 215 on both, that is a giant 1. Let's see my beautiful giant 1. It looks really fat, but oh well, work with me here. There's my 215 over 215. That's my super giant 1, or my giant 1. Multiplying anything by 1 doesn't change the value, it doesn't change the ratio, so I can do that. So multiplying 2 or 7 times 215 gives me 1,505. So if I do 215 times 10, I get my answer, which is 2,150 minutes. And that's the answer I'm looking for. So the giant 1 says multiply the ratio, the first ratio, by whatever it takes to get the second ratio. Okay, so if I have a number like 3/5, okay, and I'm trying to figure out how much it would be, question mark, and let's go with 60. 5 times what is 60? 5 times 12. Well, then 3 times 12 as well. Let's do a giant 1 right here. I do a giant 1. It must always be the same number as numerator and denominator. 5 times 12 is 60, so 3 times 12 is 36. So that means 3/5 is the same as 36 over 60, and that would be my answer. So that is the giant 1, and that is one method you can use to solve a proportion. Here comes a second method, the undoing division method. Now, this method requires a little bit of review and some other things, and here's what I want you to look at. I want you to look at a couple prompts here and see if you can find the pattern. 5 times 2 divided by 5. Okay? 5 times 2, I do that first. 5 times 2 is 10. Divided by 5 is 2. So 5 times 2 divided by 5 is 2. 3 times 6 divided by 6. Well, 3 times 6 is 18. Divided by 6. Oh, so 18 divided by 6 is 3. So 3 times 6 divided by 6 is 3. By the way, I forgot to clarify this. I want to make sure you know you do need to be taking notes on this. I do expect you to be writing this stuff down. And again, if it's getting too much, pause the video, write what you need, and then unpause it to continue. But I expect to see these notes. How about, let's go a little bit more complicated. How about 23 times 41 divided by 41? Now you're like, what on earth? What are you talking about here? Well, let's get our calculator and see what we got. So please, on your calculator, do 23 times 41. Whew. 943 divided by 41. Now, don't do it yet. Hold on. Don't do it yet. Look at the previous two problems. Look at this problem right here, and look at this problem right here, and see if you can tell me, without using a calculator, can you tell me what 943 divided by 41 is? Because if you look at the pattern that we've done in the previous two problems, you do not need a calculator to tell me the answer. Do you think you see it? Well, if you don't, I'm not using my calculator here, and I'm going to tell you the answer. Ready for the answer? The answer is 23. You're like, how on earth did you do that? Well, look at this. 5 times, back to here. 5 times 2 divided by 5 is 2. 3 times 6 divided by 3, or 3 times 6 divided by 6 is 3. 21 times 40, or 23 times 41 divided by 41 is 23. Do you notice what's happening here? When I multiply by something and then divide by that same number, by one of those numbers cancel out. You know why? Because I can take this fraction, 5 times 2, and I can split this up. I can put this 5 under either one of these numbers. It doesn't matter. So if I go 5 times 5, or 5 divided by 5 times 2, isn't this a giant 1? And that means that goes away. So this 5, multiplying by 5 and divided by 5, cancels it out. Here, multiplying by 6 and dividing by 6 cancels out. Here, multiplying by 41 divided by 41 cancels out. Isn't that cool? So I can undo division by doing the opposite, which is multiplying by that. So using that example, let's come up to this, okay? So here we go. Stick with me here. This is challenging, I know. This is challenging, but stick with me. I've got division up here, and I don't want it. And so I want to get rid of it, okay? I want to get rid of this division. And the question is, how can I get rid of it? I get rid of division by doing the opposite. So I want this x alone. So I want to get rid of dividing by 1,505. So I'm going to multiply by 1,505. But whatever I do to one side of an equation, I've got to do to the other side. So I'm going to multiply by 1,505 over here. Now again, you're wondering, why are you doing that? Because when I multiply, technically I'm multiplying by 1,505 over 1. And when I multiply fractions, I just multiply across. So I do 1,505 times x over 1,505 times 1. Well, that's just 1,505. Cool? And wait a minute, what we just looked at, look at this pattern right here. What happens with this 1,505 and this 1,505? They cancel out. What's left? Just x. So now all I have to do is solve this side. So 1,505 over 1 times 10 over 7. And again, with fractions, you just multiply across. So I multiply 1,505 times 10. Do it on your calculator. Do it. And you get 15,050 over 7. And now, will you please divide 15,050 by 7? And guess what you get? It's kind of interesting. You get 2,150 equals x, which is the same thing we got here. Look at that, 2,150. All right? So that is the undoing division problem. That's undoing division. And we are going to practice these tomorrow, so don't freak out if this is making no sense. But we are going to practice. And again, I want you to look back on this and see if you can follow along. Some of you might need to watch this video again. There is one last method we're going to talk about in this video today, okay? And that is fraction busters. Busting is to get rid of, is to catch, is to kind of eliminate, okay? So fraction busting means busting up those fractions, getting rid of them. Well, guess what? We just did part of that last time. We got rid of this fraction over here by getting rid of dividing by 1,505, right? How do we do that? Multiplying by 1,505. So if I multiply by 1,505, that's going to get rid of this fraction here. How would I get rid of this fraction over here? Well, doing the same thing. Multiplying by 7. over 1. That is going to get rid of this fraction. Now, here's the problem. I said it before for the second method, so I'm going to say it again. Whatever you do to one side, you have to do to the other side. So if I multiply the left side by 7 over 1, I have to multiply the right side by 7 over 1 as well. And if I multiply the right side by 1,505, I need to multiply the left side by 1,505 over 1. All right? So, here's what happens then. Well, this 7 cancels out this 7, and this 1,505 cancels out this 1,505. So now all I'm left with, oh, this is just 1 and 1, and now this is 1, and this is all 1 and 1 and 1. So all the denominators go away. All I'm left with then is 1,505 times 10 equals 7 times x. And to finish this off, hang with me here, we're almost done. Multiply the left side here and you get 15,050 equals 7 times x. 7 times some number is that. Well, how do I figure that out? We're going to work on this more later on. But if I divide both sides by 7, 7 over 7 is 1. See that? 7 over 7. I'm getting rid of the multiplication by dividing. And 1,550 divided by 7, you guessed it, 2,150 equals x. So there it is. 3 methods to solve proportions. We are going to practice this tomorrow. And tomorrow, guess what? Tomorrow I'm going to introduce you to a fourth method. And then I'm going to give you a chance to kind of practice and see which one you feel comfortable with. There might be one that really worked for you. There might be one that's kind of confusing. It's good to have these concepts anyway, but I'm not going to necessarily ask you to know all of them. You just need to kind of follow along with it and hopefully understand it. So that is the video for today. Your task now is to, let me see, what do I have for you? Your task now is nothing. You actually do not have to do anything at this point. That's all I had for you because the video is a little bit longer than usual. So relax, catch up, maybe make sure you've got everything done. And tomorrow we're going to practice these skills. Okay? All right, I will talk to you tomorrow.